Hi, welcome to Vision Classes. It's classes for IGCSE, GCSE, AS and A-level student around the globe. So today we have to discuss IGCSE Physics Paper 4 Extended May-June 2024 question. And this question from the momentum, kinetic energy, energy conversion topic. So before we jump onto the question, if you haven't subscribed yet, subscribe to our channel. If you want to connect with us, I have left the contact in the description box. So here question 2 says that two identical trolleys are there, P and Q, held at the rest on the frictionless horizontal surface. A load is fixed to the trolley P. So here we have a trolley P and load is fixed, which is 1.5 kg. There is a compressed spring between trolley P and Q. Here compressed spring, the trolleys are released. As the spring extends, it pushes the trolley apart. Fine. Once you release the spring, they move apart. This is simple mechanism is there. And then trolley Q moves to the right, towards the right, and at a constant speed of 0.36 meter per second. Fine. Then the mass of each trolley is 1.2 kg and the mass of the load on trolley P is 1.5 kg. The spring has a negligible mass. So calculate first part, speed at which trolley moves to the left. Now we'll understand firstly basic things. Here the spring is compressed by these two trolleys, right? So that's why the momentum of P is equal to momentum of Q. Okay, that's a basic concept. So momentum of P here is equal to momentum of Q. So here momentum of P is basically m of P times v of P is equal to m of Q times v of Q. All right, so we have to calculate the speed of P, right? Isn't it? P, mass of P here, mass of already load is there plus this trolley 1.2 kg is there. So we can add these two, 1.5 plus 1.2 times Vp, that is what we have to calculate, isn't it? Then mass of Q is 1.2 times Vq is 0.36 meter per second. Fine. And if you rearrange whole thing, Vp is equal to 1.2 times 0.36 divided by 2.7. So if you take this whole thing, that is we will get the 0.16 meter per second, means the speed of a P is 0.16 meter per second. Then second part is the kinetic energy of a trolley Q when it moves at a 0.36 meter per second. Okay, motional, when there is a motion, there is a kinetic energy. Okay, so here in this case means trolley Q is moving rightward with this velocity 0.3 meter per second, isn't it? And it involves the kinetic energy. So kinetic energy, we have a formula which is 1/2 m v square. So it's a 1/2 times m is 1.2 times 0.36 bracket square. If you put out these things in your calculator, you will get 0.078 joule. This is the unit, 0.078 joule. Fine. So this is how, means you have to solve it. Here this is for 3 marks and right answer you will get A1 as well. All right. So then nextly state the energy transfer that takes place as spring expands. Okay, so here initially when the spring is compressed between these trolleys, elastic potential energy is stored. Fine. And this elastic potential energy is converted into kinetic energy. Okay, so I will explain it again. As the spring is compressed, elastic potential energy is stored in the spring, and when it releases, this elastic potential energy is converted into kinetic energy. Fine. So EPE, elastic potential energy, is converted into kinetic energy. Fine. So that is what you have to write for 2 marks. So to know this kind of tips and tricks, you can connect with us straight away. I have left the contact in the description box. That's it. Enjoy the physics.